You know, what if I told you that our most successful, most precise theory of reality is also, well, fundamentally broken? That's what we're digging into today, this deep identity crisis at the very heart of quantum mechanics.
And this really is the central mystery we're talking about. I mean, we have a theory here that predicts the universe with just mind-boggling accuracy, and yet, at its core, there's this contradiction, this deep problem that's so profound, physicists have been at each other's throats about it for, almost a century now.
I mean, just to give you a sense of its power, quantum mechanics can describe things happening on timescales faster than 10 to the minus 40 seconds. That is just an unbelievably tiny slice of time. It's astonishing, really. But, and this is the big but, right underneath all that incredible success, there's this deep philosophical crack running through its very foundation. Okay, so what makes this particular problem so weird, so different? To really get it, we've got to understand that, not all flaws in a scientific theory are the same. They're not all created equal. See, most of the time, when a theory has a flaw, it's just incomplete. Think about Newtonian physics, right? It works perfectly for throwing a baseball, but it completely breaks down when you get close to the speed of light. But quantum mechanics? That's a different beast entirely. The problem, as thinkers like Roger Penrose point out, isn't that it has limits where it stops working. It's that it's conceptually incoherent. It actually contradicts itself from within. And this conflict, this internal contradiction, it has a name. It's called the measurement problem. And honestly, it gives the universe this bizarre kind of split personality. So, what it boils down to is this. The theory gives us two completely different contradictory rules for how reality is supposed to work. And the crazy part? It never actually tells us when to use which rule. It all seems to hinge on this idea of measurement, but it never defines what a measurement is. And look, this isn't some fringe idea I'm talking about. This is a huge, widely acknowledged puzzle right at the center of physics. So let's look at these two faces of quantum reality. Rule 1 is what happens when, no one is looking. The system just evolves smoothly, predictably. It explores every single possibility all at once in what's called a superposition. It's beautiful, it's deterministic. But then there's rule 2. The moment a measurement is made, the moment someone looks, bam, the whole thing just randomly collapses into one single definite state. All those other possibilities just vanish. And the theory gives us absolutely no physical reason why this sudden jump happens. It just does. So, okay, if the theory itself seems to be broken, how on earth do physicists try to fix it? Well, the short answer is they don't agree at all. It's a total mess. I mean, the landscape of possible solutions is completely fractured. You've got the many worlds interpretation, objective collapse theories, pilot wave theory, cubism, ideas that range from infinite parallel universes to reality just being, information. And then, of course, there's the famous shut up and calculate approach, which basically just says, hey, who cares if it makes sense? The math works, the predictions are right, so let's just get on with it. All right, to even begin to make sense of this, there are two really critical ideas we need to get our heads around. First up is something called decoherence. Now, this is a real accepted process. It explains why we don't see quantum weirdness in our everyday lives, like a cat being both dead and alive. Basically, the quantum state gets tangled up with everything around it, the air, the light, you name it, and that scrambles the superposition so fast that it just looks like there's only one outcome. But here's the catch. It doesn't actually solve the problem, it just hides it really, really well. Then you have things like objective collapse theories. These propose something totally different. They say the collapse isn't an illusion, it's a real physical process. Someone like Roger Penrose, for instance, has this fascinating idea that maybe gravity is the culprit, that when a superposition gets big enough, massive enough, its own gravity literally forces it to pick a side and collapse into one single state. It's a real physical event that we just haven't discovered the mechanism for yet. And just to see how truly strange, how mind-bending some of these solutions can get, let's zoom in on one of the most popular ones, the many worlds interpretation. Okay, so the reason people love many worlds is because on paper it's just so elegant. Mathematically, all you do is get rid of that messy random collapse rule. You just let the equations run. Simple, right? But as this quote hints, the simplest equations don't necessarily mean the simplest reality. And oh boy, the price you pay for that mathematical simplicity is a vision of reality that is anything but simple. Because in this view, the wave function never collapses. Instead, every single time there's a quantum choice to be made, the entire universe splits into parallel branches. A new universe for every possible outcome. Think about it. That decision you made to keep watching this explainer? Well, according to this theory, another version of you in a brand new universe that just popped into existence clicked on something else. And this is where it gets really unsettling. These different branches, these new universes, are completely cut off from each other. Forever. All those other versions of you and everyone you know, your friends, your family, they are just as real as you are, but you can never, ever reach them. They're gone.
Which leads to this really profound and, frankly, kind of lonely philosophical conclusion. You only share a reality with the specific people who ended up in your branch. Everyone else you started with has split off. You're essentially isolated in one single thread of this ever-splitting multiverse. And there's nothing that makes your thread the real one. You are, in a very deep sense, ontologically alone.
So where does all this leave us? Well, it leaves us with a pretty stark choice. And it's not just a choice about which physics is right, it's a choice about what kind of reality we're even willing to live with. So here it is, the big trade-off. On one hand, we could go with something like many worlds. We get beautiful, simple math, but we have to pay the staggering ontological price: infinite, unseeable universes, and a completely fractured idea of who we are. Or, on the other hand, we could stick with something like objective collapse. We get to keep our single, shared reality, but the physical cost is huge. We have to believe in and go searching for totally new and unproven physics to make it all work.
And that, right there, is the ultimate question this whole debate forces us to confront. Should the philosophical cost, the sheer weirdness or loneliness of a theory, count against it? When our best description of the world gives us choices like these, we have to ask ourselves what we really want from a scientific theory. Do we just want it to give us the right answers, or do we need it to give us a picture of reality that is coherent, and maybe even one we can live in?